Welcome everyone, this is Abdelshiheed. I'm from Egypt and currently I'm a PhD student in North Carolina State University in computer science, and today I'll be doing my talk about metacognition and motivation, the role of time awareness in preparation for future learning. So let's get started. Preparation for future learning, or PFL, was introduced in 1999 by Bransford and Schwartz. Its definition is the capacity to learn new information and invent strategies, solve new problems, and possibly new environments with the most effective usage of resources. So think of it like PFL has that view of extended learning rather than a one-shot experience. So what are the factors impacting PFL? Well, metacognitive skills and motivation were individually found to have a positive impact on PFL. However, as far as we know, no previous work has been done on the interaction of both, and that's what we exactly did here. We investigated the interaction of the two factors, metacognitive skills and motivation, on PFL across two intelligent tutoring systems, more specifically from a logic tutor to a probability tutor. So what is the study overview? We have a group of students. Some of them are highly motivated for logic, others are low motivated for logic. We make them go through a logic tutor. And throughout each problem, they can solve it by one of two strategies. A default strategy called direct proof, more like forward chaining, or they can switch on demand to another strategy called indirect proof, more like backward chaining. And we record their metacognitive skill throughout the tutor, like which strategy did you pick throughout each problem? And if you decided to switch, when did you switch? And then 7 to 8 weeks later, we make them go through over a probability tutor. We measure their motivation again. Some of them stay in the same motivation, but more specifically, these two highlighted in red changed their motivation. And then we combine the metacognitive skills measured only in the logic tutor with the motivation, once in the logic, once in the probability, and we report the observed patterns on PFL. So our findings and contributions can be summarized into points. First one, to assess PFL, we need to combine the two factors, metacognitive skills and motivation. Using only one of them is insufficient. Second one is that to measure metacognitive skills, you need to have two dimensions. Problem solving strategy, which we will refer to it as strategy awareness and time awareness, and we explain each later in details. So that's the outline. Let's get started. Hubbard and Erdős defined metacognitive skills to be the one's realization of their own cognition as well as being able to regulate it. In a more simplified way, Euclid defined it to be the act of exercising and monitoring control of cognitive skills. So according to our understanding, one way of defining metacognitive skill is that it's composed of a normal cognitive skill and a regulator responsible for controlling and maintaining that cognitive skill. In our case, we will be using time because it has been used a lot in prior work and because it's the most feasible to measure in practice. More specifically, our cognitive skill will be strategy awareness, which is which strategy did you use, and our regulator will be the time awareness, which is the when part. When did you use each strategy? Regarding related words for metacognitive skill, there have been many ways to measure it. For example, Zepeda used tutoring programs by teaching students metacognitive skills such as planning, monitoring, and evaluation, and it found that these skills helped them or made them outperform their peers on self-guided novel learning tasks. Also, she and Valen used strategy selection by teaching principal inference skills to students by drawing their attention to the characteristic of each individual domain principle, and they found that these principal inference skills were the one who closed the gaps between high and low income competent students in the domain where they were taught these skills, which is a probability, and also in the domain where they were never taught these skills, which is the physics. Regarding motivation, Euclid defined it to be the perception of three factors: expectation for success, subjective task value, and intrinsic interest, which is how, what, and why. How much success do I expect to achieve from this task? What value am I going to get from it? And why would this task interest me? Later, Tucatelli and Fishbach classified motivation into two dimensions: outcome focused, representing the people who care more about getting it done, and process focused, representing the people who care more about doing it right. There have been two main ways to measure motivation in prior work. First one is survey or questionnaire based, in which you measure motivation constructs such as self-efficacy or achievement goals, or to collect their online traces such as the use of hints and accuracy. In our case, since our study is a post hoc study, so we cannot go back and survey people, and also because we care more about an objective way of assessing students rather than possibly getting subjective responses from survey, we will be using online measures. More specifically, we'll be using the initial accuracy as our online measure. So let's start by going to the dataset and the participants. Since we're talking about 2 tutors, we only focused on the population of students who finished the both tutors. There were 495 of these students. They were undergraduate students in the discrete mathematics course in North Carolina State University across 3 semesters. And they were distributed in this following way. And as you can see, we have a little bit more students in fall 18. Let's go to the logic tutor. Here is the interface of the logic tutor. The default strategy is called direct proof, but as you can see, there is a button at the bottom. If you click it, you can switch on demand to indirect proof. So what exactly is each strategy? Direct proof, you start by givens at the top, like these 3 purple nodes. You have a conclusion at the bottom, like that purple node, and your purpose is to proceed from the givens to the conclusion by deriving intermediate nodes. Indirect proof is similar because it starts by the same givens. But this time, it starts with also the negation of the conclusion, and the target is to derive a contradiction at the bottom. Some people refer to it as a proof by contradiction, but we will call it here indirect proof. To put you more in context, on average, a single problem takes around 210 actions to be completed. An action can be something really trivial, like hovering over a node, or it can be something complicated, like deriving an intermediate node. Also, for people who decide to switch strategies, the median value of actions to do so is 30 actions. So how do you define metacognitive skills for a single problem? As I told you, we have strategy awareness, which is did you use direct or indirect? Also, we have time awareness, which is within that problem, did you switch early or late? So we have S aware, which stands for strategy aware, 1 for switch, 0 for no switch. And whenever you switch, we define T aware, which is time awareness. Did you switch early, which is less than or equal the median value of actions, which is 30 actions like I just described, or did you switch late? In such case, you take a -1, which is after the median value, which is 30 actions. So how do you define it for the entire tutor? So let's go over the structure of the tutor. As you can see, we have a pre-test level, then 5 training levels, then a post-test level. And within each level, you proceed from the left column to the right column. Each problem, as you can see, is presented by a cell. There are 2 types of cells. An empty cell, which represents the problem is flexible. It can be problem solving or word example. Problem solving, the student solved everything by himself. Word example, the tutor shows a step-by-step solution to the student. And some problems are fixed to be problem solving, like the last 2 problems in the pretest. The entire tutor is incremental difficulty. So level 1 is harder than the pretest, and level 2 is harder than level 1, and so on and so forth. Each problem has a score. The score is the average of time and accuracy percentile. So you get a time percentile, accuracy percentile based on the historical data in the same problem. And we take the average of both to conceive the problem score. For the sake of presentation and reporting, all scores are normalized to the range of 0 and 100. And we compute something called normalized learning gain, which is a function of post-test and pretest score. So what is the post-test and pretest score? Pretest is the average of the last 2 problem scores in the pretest level, and post-test is the average of the first 2 problem scores in the post-test level. And NLG, the higher the better. So positive NLG means the student learned something from the tutor. Negative NLG means that tutor harmed his learning. 0 NLG means the student didn't learn anything. So how do we compute metacognitive skills throughout the entire tutor? We iterate over the training levels, problem by problem, and we compute the S aware and T aware for that problem. And to account for the fact that the tutor has an incremental difficulty, we multiply by the level number, because the later you switch, the more savings you will achieve. So the only difference is that when we define it for the entire tutor, there is another dimension now in the time awareness, which is which level did you switch in. So each student gets a score, and based on that score, we divide students into 3 categories. First case, if the score is 0, it means the student followed the default strategy throughout the entire tutor, although theoretically it's possible that there was a positive score and negative score and they cancel out each other to become 0, but that only happened for a couple of students. Second case, if the score is negative, it means that you are a strategy-only student. You are aware of each strategy, but you're not aware when to switch between the 2. Last case, if your score is positive, it means that you are probably a top student, which means we call them strategy and time aware. And the right table contains the distribution of the student of the 3 metacognitive group across the 3 semesters. And as you can see, a chi-square test showed that there is no significance, yet a marginal difference between between all the groups. Because fall 18 had a little bit more students, so more strategy and time and more strategy only in that semester. So let's go for the motivation, but since we define motivation across both tutors, let's go first for the probability tutor really quickly. That's the training section of the probability tutor, and it is the only intelligent section in the tutor. It has a fixed strategy to solve each problem, which is a backward training strategy, in contrast with the logic tutor, in which you can pick a strategy. So it's divided into 4 phases: textbook, in which students go over textbook, learn the principles; pre-test, training, and post-test. Pre-test and post-tests are like probability exams or midterms, in which we give students space to submit their answers. We grade it like an exam by experienced graders in a double-blinded way, and we give them a pre-test and post-test scores based on their accuracy of their answers. So training is the only intelligent section. So how to define motivation? We do it once in the logic, once in the probability. And first step is you take the average accuracy in the first 2 problem solving of principal applications. So each student gets a score. Now we order students according to that score, and we do a median split. In the case of logic, it results in high and low motivation in logic. In case of probability, it results in high and low motivation in probability. When we interact their motivation with the previously measured metacognitive skills, we found that the students were split evenly across the 6 groups in each tutor. And that was verified by a chi-square test, which reported no significant difference in the distribution of motivation across the 3 metacognitive groups in each tutor. We also have no evidence for the students staying in the same motivation from logic to probability, because the chi-square test showed no significant difference in their motivational change from logic to probability. So let's go for the results. The actual paper have a lot of statistical results. I'll be highlighting the most important ones here. So we're talking about the post-test first. On the left, there is logic. On the right, there is probability. And each diagram, as you can see, there are 3 metacognitive groups. In each group, we have high and low motivation. So in order to verify that the way you split students was independent or unbiased to their incoming competence, we did 2-way ANOVA on the pretest, and it found no significant difference in their pretest score in each tutor. So let's start by the left figure first, like the left half of the slide, which is the logic post-test. We started by doing it 2-way ANCOVA, using the 2 factors, metacognitive skills and motivation, and pretest as a covariate. There was no interaction effect. However, each factor had a main effect. But the takeaway here is that there was a single dominant group, the high motivation strategy and time. Contrast test found that it outperformed both high motivation strategy only and also high motivation default group. Let's go now to the probability post-test. We did the same. We started by doing a 2-way ANCOVA, covariate pretest, the same 2 factors. So there was an interaction effect. But the takeaway here is that there was 2 dominant groups, high motivation strategy and time and high motivation strategy only. Both of them outperformed the high motivation default group. So let's go for the NLG. In case you forget what is that, I'm putting the formula at the top. Logic NLG on the left, probability NLG on the right. Let's start again by the logic NLG. And let's see if we have the same patterns or not. And surprisingly, we will have the same patterns in both cases, logic and probability. So we did a 2-way ANOVA using the same 2 factors on the NLG. There was no interaction effect, no main effect. But surprisingly, again, the same patterns existed. A single dominant group, high motivation strategy and time, outperformed each of high motivation strategy only and a high default group. Similarly, in the probability, with the 2-way ANOVA, there was an interaction effect. And again, the same patterns existed. 2 dominant groups, high motivation strategy and time, and high motivation strategy only. Each of them outperformed the high motivation default group. So if I ask you a question right now, who is prepared for future learning? Since I'm talking about learning, you have to look at the NLG. And since I'm talking about PFL, you have to look at the probability tutor, because it is a second tutor that students complete. So which groups are you going to pick to be prepared for future learning? I think you're going to pick these 2 groups. That's correct. What do they have in common? Both of them are highly motivated, but more importantly, both of them are strategy aware. And that's the purpose of strategy aware here, examining the PFL. Second question, what is the role of time awareness in PFL? Well, we have to compare these 4 groups. The 4 groups have high motivation, but the 2 blue ones are both strategy and time aware, and the 2 red ones are only strategy aware. What is the difference between the 2 blue and the 2 reds? Yes, consistency. Both of them, the blue ones are consistent while the red are not, provided that they are highly motivated. Third question, how robust is the interaction of the 2 factors? Well, focus on this one for now. I will show you exactly the same figure, but only with the metacognitive skills ones, and then only with the motivation ones. And you'll see that the patterns stop to exist. Let's start by only the metacognitive skills. Let's focus for now on the right bottom figure. It has only metacognitive skills on the probability NLG. As you can see, there is no difference between the 3 metacognitive groups, because we are basically combining the high and low motivation within each metacognitive group. Again, let's look at only the motivation. Again, the right bottom figure only. There is a difference between the high and low motivation, and the difference is significant, but the gap is not that big. So our conclusion, first of all, what is the role of strategy and time awareness? Strategy is it's examining the PFL, provided that students are high motivated. Time is the decisive factor of consistency, provided that they are motivated. How robust is the interaction of the metacognitive skills and motivation? There was no evidence on PFL if you only use the logic features, but when you consider additionally the motivation, more specifically the high motivated students, you find the evidence. The limitations, first of all, it's a post-hoc study, so you can claim correlation, not causation. We only use initial accuracy for motivation. We didn't try other alternatives, or we did not use more measures. We have no evidence on the behavior of default students. Was it their own choice to follow the default strategy, or they were never aware of the other strategy? Future work, you can design interventions to help the students in need, like more specifically the low motivated students, by predicting their group label early and intervene to help them. You can try other metacognitive or motivational measures. And since the strategy is shown to examine PFL, why not teach it to students? Thank you, everyone. I'll be happy to follow up after the presentation in the live chat to answer any concerns. But if you want to ask me any question, you can drop me an email on my university email, or you can follow me on ResearchGate, LinkedIn, Twitter. I go by the same name, Abdelshiheed. Thank you, and have a good day.